let's talk about polynomials. Polynomials are a group of expressions, group of functions, some of which you've seen before. These are linear expressions. They have just one variable in them. These are quadratic expressions. They have just one variable, but they can be at power of 2 and maybe also a power of 1. These are just part of a much bigger group of functions called polynomials. It's anything where you have one variable with whole number of powers. Here we've got 3, 2, and in fact this is x to the power of 0. Think about it carefully. This is a polynomial. We say it has degree 3. 3 is the highest power of x in this function. Another name for a degree 3 polynomial is cubic. I'll come to those names in a minute. Here is a polynomial of degree 7. It's only got x in it, it's the only variable, and it only has whole number powers, power of 0, power of 3 and power of 7. And 7 is the highest, so that's the degree. Conventionally, we would normally write this the other way around. 3x to the 7 minus 4x cubed plus 1. We normally write them with the highest power first. So how do I decide if something is a polynomial? We just look to see, has it only got one variable in it? And if so, what are the powers? It's got to only have powers that are whole numbers, 0, 1, 2, etc. So this one is a polynomial. This one's not a polynomial. It has only one variable in it, but that variable actually has a power -1. It's on the bottom of the fraction. That's not allowed in polynomials. This one almost looks like a polynomial, except again this power is 1/3. It's only allowed to have whole number powers, so this is not a polynomial. This one's not a polynomial either. The square root, remember, is actually the power 1/2. So this is not allowed in a polynomial. This one is a polynomial. Although it's missing x cubed and x to the power of 1, it does have only one variable, x, in it, and that variable x only has powers 0, 2 and 4, which are whole numbers. This is a polynomial of degree 4. Now opinions differ on whether this one's a polynomial. I say yes by the definition. It's really 5 times x to the power of 0. But it's a pretty trivial polynomial because it's just a constant. When we look at the definition of polynomials, here's the formal definition. It says it's got x to the n minus 1, x to the n minus 2, all the way down to x to the power of 0. N is a whole number. The degree here, n, is the highest power of x in this expression. The constants are called coefficients. That's the same word as we use in algebra anyway. The number in front of the variable, this number is called a coefficient. This one at the end is just a number. Remember, it was just -6 or 1, like this one isn't actually a polynomial, or actually just the 5. It's called the constant term because it's constant. It doesn't actually have a variable in it. This one is called a leading term. You won't hear that very often, a leading term. It is a leading term. The important thing to know is its degree. It tells you what degree the polynomial is. Some names of common polynomials. If it's just a number, it's a constant. If it is just degree 1, power 1, it's linear. Degree 2 is quadratic. Degree 3, you've probably heard before, is cubic. Degree 4, I'm guessing you haven't heard before, is quartic. There are many other names based on the extension of these words. Usually beyond even about 3, we'll start talking about of degree 5, of degree 8. I also want to introduce you to notation that we use for polynomials. We write them using function notation. You may not have seen this before. We give a name to the polynomial p, and we write it p of x. So we say this p of x. P of x is a polynomial that means 2x cubed minus x, in this case. Why do I do that? Because it makes it easy for me to write a substitution. So if I'm looking at P of x and want to know what its value is when x equals 3, I just write P of 3. And that means get my formula for the polynomial, and wherever x is, plug in, substitute the value 3. And I can evaluate this polynomial P at x equals 3. I can evaluate the same polynomial at a different point. Evaluate this polynomial at -1. Put x equal to -1 in and work out its value.